Code to Enhance Learning presents the CEL video series for creating projects that integrate computing with the world around us using Arduino Uno. Through this video series, we aim to introduce you to the world of physical computing and the Internet of Things.
Hello everyone, I am Ayush Sankaran, an enthusiastic coder and a regular CEL hackathon participant. I will be your host for today.
Welcome to the final episode of the series LED Patterns. In this episode, we are going to create a simple digital art comprising of LEDs. The LEDs will make different blinking patterns. Digital art refers to any artistic work or practice that uses digital technology as part of the creative or presentation process. From simple blinking LEDs to interactive digital art, this space has come a long way. Besides being widely used by engineers, programmers, and electronic enthusiasts, the Arduino platform has also made its way to the art/design industry, especially because of how easy it is to use. In this session, we are going to create a simple digital art comprising of LEDs. The LEDs will make different blinking patterns. Let us look at the components we will need for our project. We need the Arduino microprocessor, the breadboard, the jumper wires, LED lights, and the USB cable to connect to the computer. Now let's see how to create the circuit. First, take 8 LEDs and connect them with the breadboard as shown in the circuit image. Parallel to cathode LED connections, insert a connecting wire and connect it to GND. Starting from first LED anode connection, insert connecting wire to Arduino digital pin 2, second LED anode connection to Arduino digital pin 3, and so on till all 8 LEDs are connected. Now let's make the connections. First, take 8 LEDs and connect them with the breadboard with the smaller leg cathode at the top and longer leg anode at the bottom. Parallel to cathode or smaller LED leg connections, insert a connecting wire and connect it to GND. Starting from the first LED anode connection or longer leg, insert connecting wire to Arduino digital pin 2, second LED anode connection to Arduino digital pin 3, and so on till all 8 LED connections are completed. Finally, we connect the Arduino to our computer. Now our connections are complete. Now let us move on to coding our project. We have opened a new project in mBlock using the mLink driver and signed into our account. If you do not know how to do this yet, please view the first video in the series. Once you have signed into your account, you can rename the project to call it LED pattern and save your project. Now let's add Arduino to our project. I click the Add button and select Arduino Uno from the list. Then I click the Connect button. Now you'll see that the device is connected to our project. I go to the Events tab and bring when Arduino starts up. I open the C editor so you can see the codes in C language as well. Now I'm going to create a few variables needed for our project. The first variable I'll create is called LED pin first. The next variable is called LED pin last. The next variable is called K. The next variable is called J. The next variable is called I. The last variable is called pattern code. I have created a total of 6 variables. Now I'll set the value of these variables. I set the LED first to 2. Next, I set the LED pin last to 9. This is because we are using pins 2 to pin 9 of the Arduino board to connect the LEDs. Next, we set the value of K to LED pin last. Next, we set the pattern code to number 3. We are going to create 3 patterns, of which we are going to do the demo for only the third one. For the first and second pattern, I'll just show the completed codes and you can try it at your end later. I'll bring a forever loop from controls and check if the pattern code equals to 1. If yes, we will create a new pattern using mBlocks, which I will call as P1. I will use P1 block here. Now I get a new block to define P1. As I said earlier, I am not going to define P1 now. I will define it later. I'll duplicate this and check if pattern code equals 2. I'll create another block and call it P2. I will not define P2 now, but I will use P2 here instead of P1. I'll do this once more. For pattern 3, we'll be defining it now, so that you can do pattern 1 and 2 at your end later. So for pattern 3, I'm going to set the value of I to LED pin first. Then I'm going to bring a repeat until block and check if I is greater than j. Then I bring the digital pin value block. Sorry, this is not j here, this is k. I is greater than k. Set digital pin I output as high and then wait for 0.1 seconds. I am going to repeat these two blocks. This time, digital pin output will be low. Then I change the value of I by 1. Now for the outer loop, I'm going to change the value of k by -1. Then I'm going to set j to LED pin last. Now I'm going to bring a repeat until loop. Next, I'm going to bring OR operator as I'm going to check two conditions here. If j is less than k or j is equal to k. If either of the condition is true, we set digital pin j output as high. Then I'll change j by -1. After this, I'm going to wait 0.5 seconds. Lastly, I'm going to bring an if block and check if k is equal to LED pin first. If yes, then I set k to LED pin last. Please recheck your pattern 3 code by pausing the video. This brings us to the end of defining pattern 3. Now I will show you codes for defining pattern 1 and pattern 2, which you can write on your own. Once you have done this, you can upload your code to Arduino. The code has successfully been updated. Now let us see a demo of the project. Let us test our project. As you can see, the LED lights are blinking in the pattern 3 which we coded, which looks so beautiful. We have a fully functional project now. What more can you do with the project? You can try pattern 1 and 2 by writing the codes on your own and testing it to see how they are different from pattern 3. You can try and create your own patterns as well. This was the final episode of this series on physical computing. I hope you enjoyed learning so many interesting projects using the Internet of Things. I had a lot of fun hosting this series for you and hope you enjoyed this as well. Thank you CL for providing such engaging projects using simple hardware tools. This is Ayush signing off. Bye.